we're really light on humans. I'm really glad I'm not doing anything that's going to be like killer brain power stuff today. So let's see, it has stopped blinking, the red light is on, so I'm sure that the beginning of every one of these recordings is absolutely fascinating for anybody who's listening to it. So just to let you know, let me go back to this. Just to let you know, this morning I posted in the announcements, and I'll actually be putting it as well over in the exam information, but I posted a 78 question final exam review. I made sure that every single topic that's covered on the final exam appears in those 78 questions. And so, and some appear closer to the front, and some appear closer to the end, and some are right in the middle. But every single topic, I went and did a one-for-one. You know, some of the wording may be slightly different, the situation might be slightly different, but I'm going to tell you that every single thing that's on that final exam is there. I'll talk more about the final on Wednesday because I'll have everything up and posted because I've been a little slow to do that. And we'll be able to play What Do I Need to Get on Wednesday, all that other cool stuff that we do. But I'll give you just a little information on the final. The final consists of you might either call it 24 questions or 26 questions, depending on how you want to think of it. It consists of 20 multiple choice questions, of which there are varying levels of difficulty and amount of space and work that you would need. And then it consists of 6 part 2 questions. You will choose your favorite 4 of them. So that's why I said there's either 24 or 26. And what I will ask you to do is clearly cross out or show me which ones you don't want me to grade. Otherwise, if I can't tell, I'll grade the first 4 that I come to that have writing in the box, or you have writing in the space. The part 1 multiple choice, because I will tell you, I'm not a fan of multiple choice on a final. It makes everybody's life easier to grade, but it usually means lower grades for some folks. So I did like I did in pre-calc. There's a left column, which is the questions, and there's a right column, which is a place to show your work. Showing your work gives you the opportunity to get some partial credit. And the way that I do that is any question you get wrong, I look to see if there's work there for partial credit. So if you get the question right, I don't frankly care how you got the question right, what the work was that you did. I'll just go back to any question that was wrong and look to see if there's something there I can give you points on. So, you know, if you're sure of your answer, you probably don't have to give work, but probably not a bad thing to give as much work as you possibly can or as much of an explanation as you possibly can. So it's not, so that's kind of the way that happens to go. So, you know, is it an easy final? No, it's not. Don't rest on your laurels. It's not super easy to do that. Make sure you read the questions. You know, leave the ones that you're not sure of and come back to them, because we do just have the 2-hour time period. So on Wednesday, one of the things that I will be posting before Wednesday is a point breakdown that'll tell you how many points come from Chapter 1, which, as I'm thinking right now, and I might be wrong, but I'm thinking there's nothing prior to the limits part of Chapter 1. I think the last section, one of those last couple may have had some limits, but there's very, very little from Chapter 1 because anything that's, even that's limits tends to revisit itself as part of the L'Hôpital's rule stuff. So it's primarily 2, 3, and 4. Lots of 3 and lots of 4, mostly 3 and 4. So it's, I don't think it's a horrible exam, but like I said, it's not gonna be the easiest thing in the world. So let's see. Last class we did the left sum, right sum piece, and I warned you there'll be a left sum, right sum question appearing someplace on the exam. Left sum, right sum, upper sum, lower sum question. Only one. Don't panic over it. But there will be a couple of other questions that have to do with antiderivatives. And so I want to make sure that I hit some of the antiderivatives. And the one big thing I want to make sure I hit are some basic antiderivative rules, some of which we've already talked about, but really what I'd like to do is I'd like to just throw kind of the ones that I would expect that you would know on here and on the screen just so that we all have them. So that's really my big plan, and then I want to do a couple, I'm going to do a bunch of explanation or computation questions with them. So here's kind of the rules that we want to make sure we have. And I'm going to use the antiderivative notation just because I think it'll be most comfortable for everybody. So the antiderivative of a constant, and again, the integral symbol, that's what I call the S, is the integral symbol, and the dx are part of the notation. Once we get to the rules, we don't really do anything with them. They're just notation. So the antiderivative of a constant is a constant times x plus c. And what I'll do in each case is I'll do an example or two. So in other words, the antiderivative of 2 dx is 2x plus c. And I could change the letters, right? The antiderivative of 5 dt would just be 5t plus c. The d, whatever, just tells us what the variable is. Antiderivative of x to a power is x to the power plus 1 divided by the power plus 1 and then plus c. And I do need to make a statement that that's as long as the power is not -1. That's a special case. And I'll show you that one. That'll be the next rule. We mentioned it, but just so that you know. So, antiderivative of 5 dx, x to the 5th dx, excuse me, is x to the 6th over 6 plus c. By the way, remember, the cool thing when you do antiderivatives is you can check your answer. All you have to do is take the derivative, and it should get you back to where you started. That's one of the coolest things. Just so we do a few of the weird examples, I'm going to do a couple of weird examples. Antiderivative of the 5th root of x to the 3rd. Just like when we do derivatives, best thing to do before we do anything is to rewrite it as a fractional exponent. I guess my phone's going to make all kinds of noises, so let me turn the phone noises off. Some days it makes no phone noises. Today it's going to be a noisy phone. It'll vibrate, but that'll be it. So now we add, or we do the antiderivative. So that's x to the, and I'm going to write this out in baby steps, 3/5 plus 1 over 3/5 plus 1 plus c. Remember when we took derivatives, I said subtract the numerator minus the denominator and put it over the old denominator? When you do antiderivatives, you actually just add them. 3 plus 5 is 8. So we end up getting x to the 8/5 over 8/5 plus c. And then the only thing that's a little squirrely with some of these that have the fractional exponents is you never see, if this were a multiple choice question, you would never see the answer written this way. What they would do is they'd say, oh, when you divide by a fraction, that's the same as multiplying by the fractions, flipped, reciprocal. And so that would be 5/8 x to the 8/5 plus c, multiplied by the reciprocal piece. Let's do one more. I'll break this up. I might do two more. If I had it as a fraction, just like with derivatives, you can't just do the fraction top and the bottom. What you actually have to do is rewrite it as x to a power. So I'm going to first rewrite it, and hopefully you all recall that the fourth root of x is x to the 1/4. But again, I can't just take the antiderivative. I have to bring that up and write it as x to a power. So it's important that I rewrite that as x to the negative 1/4 before I do the antiderivative. Just like when I do derivatives, I need to write it as x to a power before I take the derivative. So the antiderivative, and again, remember, we add, and I'm going to do it in the baby steps here. But notice if we do the same thing, if I assign the negative, say, to the top, if I add those, negative 1 and 4 gives me 3. So it's going to give me 3/4, and again over 3/4. And just like I said before, dividing by 3/4 is the same as multiplying by 4/3. So if you're wondering what I just did, I just drew lines here. One last one before I move to the next rule. If I actually wanted to do suppose I wanted to do this, where I had 2x to the 5th plus x to the 3rd over x. Again, you can't just do the top and the bottom. This is one, we did this back with derivatives, and it's been a really long time since we did this. We have a fraction that has that single item in the denominator, a single power of x. Your best bet, and in this case your only bet, is to simplify by breaking this up into separate fractions. So 2x to the 5th over x plus x to the 3rd over x, which is the same as having 2x to the 4th plus x squared. Now it just follows the basic rules. The one thing I haven't said, if we have a constant multiplied by this power of x, just like with derivatives, the constant's along for the ride. So I'll have 2 times. The antiderivative of x to the 4th is what? Yep, x to the 5th over 5. And then I do the same thing here. That would be x to the 3rd over 3. The next rule, and this is the rule, remember I said if we had p not being equal to -1, the next rule actually is the one that applies to this, and we did actually talk about it last class. 1 over x dx, if I want to take the antiderivative of that, probably don't want to do what I'm going to do, but I'm going to write down, if you kind of go into this kind of blindly, you might go, oh, well, isn't that the same as x to the -1? Yup, it is, isn't it? But watch what happens if I try to run the rule. I have x to the -1 plus 1 over -1 plus 1. That gives me x to the 0 over 0, and I don't know what the heck that is. So we don't do that. What we do remember, we mentioned this last time, is the antiderivative of 1 over x is the natural log of x plus c. And I said last class that we put the absolute value on so that we don't have to worry about negative numbers. So far, rule 1, rule 2, rule 3. I have a handful of others. It's going to feel like a little bit more than a handful. A handful of others. These are probably the biggies. These are the ones that people use the most. The next 3 that I write down are probably the 3 that would be the next most that people would use. Antiderivative of e to the x. Anybody want to take a wild guess what the antiderivative of e to the x is? It is e to the x, you're right. This is the best and coolest antiderivative. It's the only antiderivative we will do that is its own antiderivative. Notice, by the way, and this is true for any exponential function, the antiderivative of an exponential function is always exponential. The antiderivative of an exponential function is always exponential. Probably a nice little fact to tuck into the back of your brains on the last week of the semester, ladies and gentlemen. And about this time on Friday, that might help you out. No hint intended, of course. But the antiderivative of an exponential function is always exponential. That's really one of the only rules that we can make a statement about. You know, we can talk about the antiderivative of polynomials and things like that, but you know, this one's the biggie. I'm going to do what I'm going to call Rule 4a. Not one I'd lose a whole lot of sleep between now and the final exam with, but I'm going to kind of sort of derive it. But recall that the derivative of a to the x is a to the x natural log of a. That's probably going to appear on the final exam. And what's really true actually ends up being the antiderivative, if I go backwards, of a to the x, ends up being a to the x divided by the natural log of a. So if you take the derivative, you multiply by the natural log of a. If you take the antiderivative, you divide by the natural log of a. I don't think I'd lose a lot of sleep, like I said, for the final exam on the antiderivative, but it is kind of a nice little fact to tuck away. So it's Rule 4 is the one that's Rule 5 and Rule 6. And by the way, these are, I'm just numbering them. These are not like official numbering. They're just kind of the way they're coming into my brain. Rule 5 and Rule 6 are the antiderivative of cosine and the antiderivative of sine. I'm pretty sure that most of you, without much thinking, will recognize that at least a part of each of these is the opposite trig function, the opposite trig function. And I'm sure that if I said that you'd go, okay, I bet the antiderivative of cosine has something to do with sine, and the antiderivative of sine has something to do with cosine. Just like with derivatives, one of them is positive and one of them is negative. And so be a little bit careful. And really the way that I do it is I go backwards and I say, okay, which one's the one that gives me the negative when I do the derivative? And it has to be the, and so I'll do the derivative of each and figure out which one should have the negative sign. So actually look at this and I'll go, okay, if I wanted to get back, I would take the derivative. And the derivative of sine is cosine, positive cosine. So that antiderivative is positive. But the derivative of cosine, if I go backwards, derivative of cosine I know is negative sine, and so that's the one that has to produce the negative. That's the trickiest part of those two. Wouldn't be surprised to see those two tested on the final exam. Both of them, to figure out which one's positive, which one's negative. And can you imagine the multiple choice question? Because the multiple choice question, you could have A, B, C, and D, and just flip-flop all the signs. You got plus, minus, minus, plus. That's great fun. I'm going to give you the other 4 trig function antiderivatives. I do not recall, I don't believe, I don't want to say I don't recall. I'm just about positive that you don't see these others, but, if it were me, for good measure, on the piece of paper, and again, I'll talk about this on Wednesday, but just like with pre-calc, one piece of paper, both sides, anything on it your heart desires. On the piece of paper, I'd probably write every one of these rules down anyway, just to make sure. So, Rule 7. And we have to give them in special form. You'll notice it's not the antiderivative of secant. Remember with the derivatives? We did sine, cosine, tangent, secant, cosecant, cotangent. No, these we actually literally give you the derivative rules backwards. So secant squared was one of our derivatives. Who was it the derivative of? Tangent, yeah. I'm going to call these 7a and 7b. We'll just pair these together. Antiderivative of cosecant squared. Who had the derivative that involved cosecant squared? Cotangent. And remember, that was the one that was negative, so its antiderivative is also negative. Antiderivative of cosecant squared is negative cotangent. Antiderivative, let's see, whose derivative was secant x tangent x? Secant. So that's the antiderivative. It's like Jeopardy. What gave us this? Oh, this is what gave us this. And then the companion with it is the antiderivative of cosecant x, cotangent x. And that's going to give us the negative cosecant. Again, that last set, those 7s and 8s, don't believe that they're even on the final exam. Usually at this level, we don't get really focused on those. But those of you who go on to Calc 2, they'll hit you in the face real quickly. And so it's good to say, okay, I've seen them, and kind of keep them in the back of your mind. I have 2 others that I'm going to give you that, again, are not, to my knowledge, on the final exam, but they're good ones just to put in your brain for those of you going on to Calc 2. And this one in Calc 2 we spend a lot of time on. It's the antiderivative of 1 over x squared plus 1 dx. Again, not... This one I'm like 99.99% sure is not on the final exam. As an antiderivative. Does anybody remember whose derivative is 1 over x squared plus 1? It's one of the last ones we talked about. You're close. You said tangent, didn't you?
Yeah.
You're real close. It's not tangent. It's the arctan.
Oh, yeah.
Arctan. Yep. This one you spend in Calc, if you go into Calc 2, you spend a lot of time on that one. And then its companion, 1 over the square root of 1 minus x squared dx, is arc sine. You got it. Again, not on the final, but since we have some time, and I'm not talking like Alvin, Simon, and Theodore today, that it's good to kind of have them. One of the things that I've been really happy about is the folks who've come here to JCC and taken Calc 2, I usually get some pretty good feedback about the fact that you guys feel more prepared or better prepared on the beginning of Calc 2 than my colleague. And as I told you, my colleague, he's doing the Alvin, Simon, Theodore thing. Actually, I think he's taking the notes and just handing them to the students and say, you got to learn these on your own, just about. So you guys will have a little bit better preparation. So those are all the rules. Now, I just want to do a little bit of computation with them, just to remind ourselves. And again, that computation I want to do is what last class I called the fundamental theorem of calculus. And that's the rule that says if I go from A to B of something that's a derivative, because remember going backwards, I'm actually giving you the derivative, so I'm getting the thing that's not the derivative. So I do this, not the derivative, and the notation I tend to use is this up and down bar. And what that means is take the not derivative and substitute in B and A, the upper and the lower number. And when I say higher and lower, I should warn you, again, we will not do this to you in Calc 1. Change it over to me for a second. We won't do this to you in Calc 1. When I say higher and lower, physically what we mean is the number that's written at the top and the number that's written at the bottom. Typically, the number that's written at the top is the larger number at the bottom. But if somebody was trying to trick you, and they flipped them, you would still take the number that's written at the top minus the one that's written at the bottom, even if it's smaller. It's always the higher written number to subtract the lower written number. Again, we don't do that to you on the final exam. That's a Calc 2, we want to be a little bit tricky thing. So if, for example, I wanted to do the antiderivative from 1 to 3 of x squared dx. And I want to get the exact value. What I do is I just start and take the antiderivative of x squared, which we all know now is x to the third over 3. Again, when we have these numbers, we don't need the plus c. We only use the plus c when we don't have the numbers, when we're getting all of the antiderivatives. This is actually a specific example. And then what we do is we plug the 3 in first. So we do 3 to the third over 3 minus 1 to the third over 3. So I just plug those numbers in. And so that's going to give me, and I'm going to, instead of doing the full math, I'm going to say that's 27 over 3. And 1 over 3, I know that's 9, but it makes the arithmetic easier if I just leave it that way. What this is giving you, just to refresh your memory, kind of thinking of it almost in reverse, is what this is actually giving us. If I graphed x squared, and I mark off at 1, and I mark off at 3, what that actually is giving me is that area. From a calculus standpoint, that's what that's giving me when I do that computation, is it's giving me the area under x squared between 1 and 3. Where when I take the derivative, it gives us slopes. So derivatives give us slopes, antiderivatives give us areas. I can't make the problems get any more exciting. It's only the antiderivatives that get more exciting. The process is exactly the same. There's one other question that you could see. And here's here's the question. Suppose little f at x is the derivative of big F at x. I could have used primes, but this is, your textbooks tend to use this. Or I could say, said another way, big F at x is the anti-derivative of little f at x. So the big one's the master function, the little letter is the derivative of it. And we can say that forwards or backwards. So, suppose f at x is 2e to the x, and I know f at 0 is 5. What I want to do is find the function f at x. First time you read this, you're like, oh my goodness, what the heck does she want me to do? Well, I know little f at x. The way I get to big F at x is I just find the antiderivative, right? So to do this, since I know little f at x, I just take its antiderivative. It's just 2e to the x. The 2 is along for the ride, and we said a minute ago the antiderivative of e to the x is e to the x. And then this is not one of those compute. It doesn't look like this question. So it has to have that plus c. Well, once we do that, this is kind of step one. For step two, we then take this information that we were given and we plug that in. And so what I know is f at x is going to look like big F at x is going to look like this. What I do is I use that information and I plug it in to figure out what C is. What happens is that information is the information that tells me the exact C I want to use. And that's the purpose in this problem, is to find the exact value of C. So I plug in 5 for this whole thing, and 0 in for x. Because I'm really doing f at 0. I put the 0 in for the x, f at 0, which I know is 5. And so I do a little bit of quick math. So 5 is equal to e to the 0 is, so this whole thing is 2, plus c. So c is 3. Final answer. That doesn't get any more exciting than that. What do you think? Think with a little review, a little studying of it, that you'll be pretty good at this stuff? Would it be killer stuff if you had some of the questions like we did today on the final exam? No. What happens when I have a light crowd, y'all? It's like, okay, grand total of 4 humans here. Mostly guys, or most of my guys and none of my girls, right? So do we feel pretty good Am I okay with this stuff? Yep. What do you think? I've got about 23 minutes. Want me to pull up the review sheet and want to go through a couple of review questions? Let's do some related rates. Hey, that sounds good. Can I pull up the review sheet and do the related rates? I have several of them on the review sheet because I know how much you love them. No. At least you're honest. Oh, let's see. Sort by date. One of the related rates questions I have on here, let's go back to this, is question, where'd it go? Right there. Question 15. Get to it so you can see it. A right cylindrical tank. So let me slide this right there. Zoom in enough that we can see it. So this is on the review sheet, question 15. A right cylindrical tank is filled with water. The tank stands upright and has a radius of 20 centimeters. How fast does the height of water in the tank drop when the water is being drained at 25 cubic centimeters per second? First of all, how do I know it's a related rates question? Yeah, I've got some constants. I have rates in here that have time in them, don't I? But I don't have a formula, and when I look at it, I don't have a formula that has a T any place in it. So when I talk about a right cylindrical tank, I'm referring to a soup can shape. A right cylindrical tank means I'm going to have a soup can. And it stands upright and has a radius of 20 centimeters. So let me go to a new piece of paper. So, the radius is 20. What's important on this particular one that's very different from some of the others we've done is the radius is 20 centimeters at the top, it's 20 centimeters at the bottom, it's 20 centimeters in the middle. Because the radius is always 20, we can actually use 20 any place in the problem. When we did the cone questions, I couldn't use the radius because the radius at the top of the cone is different from the radius at the bottom of the cone. The other piece of information that they gave us is that the water is being drained at 25 cubic centimeters per second. Based upon the units, what is that they gave me? The volume, the rate of change of the volume. So this is dV dt, because those centimeter cube per second is dV dt. Positive or negative? Ryan tells me it's negative because drained means the volume is decreasing. So hence the negative. And the question is being asked, how fast is the height changing? How fast is the height changing? First of all, if we're draining, when we get the answer, should the height changing number be positive or negative? Yeah, negative because the height's going down. So what I need though is I need the volume of the can, because this is talking about volume. What's the formula for the volume of a soup can? Yep, IR squared H. Now remember, just like we did the cone questions, we can't have both R and H. But this is a nice question. It's actually a little bit simpler because we've already said the R is always, always, always 20. So this is the one case where I can plug in my R. So there's the formula I'm going to take the derivative of. We'll do the cone question. I just want to do this one. It was earlier on in the questions, and it's a little bit easier. Now we take the derivative, and take all of our derivatives in respect to time. So dv dt, 400 and pi are along for the ride. Take the derivative of h, which is 1, but then we just do dh dt. Now we know dv dt is minus 25, 400 pi dh dt. Question's asking us how fast the height is changing, so it's really asking us what's dh dt? So now we just solve for this is going to be 1 over 25 goes into 100 4 times, so it must go to 400 16 times. And the correct units would be centimeters. What do we think? Yes?
On the final, are all the shapes going to be shapes we've covered?
Yes, they will. Yep. Cylinders, cones, spheres, circles, rectangles, squares, those are the shapes that I would make sure that I had the formulas for. If I were you, make sure I know or have the volume of a sphere, a cone, the cylinder we just did, and a box. You know, I know surface area. By the way, I'm giving you way too many choices. These are not all on here. Don't freak out on me. But I know surface areas of boxes, spheres, you know, areas of rectangle, square, which I know are really, you know, all squares are rectangles, but rectangles, squares, circles, and I know perimeter of rectangle, square, and circle. The only reason I pulled out the square versus the rectangle is because for area, you want to realize or remember that the area of a square is side squared, and the perimeter is 4s. Sometimes students can forget that, and they get lost in the perimeter of a rectangle formula, and they forget that all the sides are the same length. Other geometric formula that I would make sure that I remember. Right, Pythagorean theorem. I know that I'm treating you like you're really long ago, but the old a squared plus b squared equals c squared. To my knowledge, those are that every single geometry formula that you're going to use on this exam is in that list. But the list has way too many. You know, there's really only one, maybe two related rates question. I will tell you, remember I told you there's that option of 4 out of 6? One of the 4 is a related rates question or involves a related rates question. I'm trying to recall, I do not think, but please don't quote me, I don't think there's a related rates question in the first part, which I think is the reason why I stuck one in the second part. But I certainly wanted to see the full gamut there.
Is there a pizza box question?
Is there a pizza box? I can't specifically say that, but there is a cutting the corners out question on the review sheet. You might want to look at that. You want to look at the pizza box question?
Yeah.
Why not? Let's look at the pizza box question. Let me dig out the pizza box question. So, want to take a look at the pizza box, which is not a related. I'll come back and I'll do another related rates question. Let me take the 5 minutes to talk about pizza box. Remind me, on Wednesday, the first thing I say, oh, what do we want to do? Say, you said you would do a couple more related rates questions. Just remind me. So, here's our pizza box. Let me draw the picture. And everybody there is x. This is 10. This is 18. Oh, sorry. When we fold up the pizza box, when we fold this up, this right here is going to be the base of the pizza box. That's what's going to be important for us to figure out how big that is. It's going to be important to figure out how big that particular item is. This dimension is probably a little bit easier to get on it. That dimension is going to be 10 minus 2x, because it's 10 high, and we're only taking out 2x.
Just on our last exam.
Yeah. Now, if I look at this, what I know is if I take 18, which is the whole length, and subtract out all 3 x's, 18 minus 3x, here's the whole 18. When I take out those 3 x's, what I'm left with is this and this. Is that the base of the pizza box? No. What is it?
Divided by 2.
I need to divide by 2. It's actually twice as big. So if I wanted to, it would be 9 minus, what'd you say? 3 over 2x, 1.5x. Now the cool part is on the exam, if you happen to not get that quite right, but you did all the calculus from here on, life's okay. Now, let me ask you a question before we ever go any further. Before I even set it up, what values of x are even legitimate?
Positive numbers.
Positive numbers. So first we know x has to be bigger than 0, but less than 5. Let's make sure here if I did 5 times this, yep. Notice here, one of the things I need to do, clearly on this part, x has to be less than 5. Oops. Because if I get bigger than 5, what about, let's double check here. If I look at this, I'd actually be doing 9, and I think that's 6, isn't it? Is 1.5 9 divided by 1.56? 6 times 5 is, I think it is, isn't it? I haven't done any calculus yet.
Yeah.
I think that's
What is it?
Yeah.
Why is it 5? Is that what you said?
Yeah.
Yeah. Perfect question. The x is the amount that I'm cutting out. If I cut out 5, and I cut 5 out of here and 5 out of here, I've cut away the whole side.
Oh, I see.
And if I cut more than 6 out of here, if I make this 6, and this 6, and this 6, then I've cut away the whole 18. So what I need to do is figure out where the x kind of suddenly collapses on me.
Makes sense.
Yeah. Now if I were going to do the problem, I would just do length times width times height. So that's 10 minus 2x, 9 minus 1.5x. There's my length, my width, or whatever order. I guess I got it backwards. Width, length. Doesn't really matter. How deep would the box be? X. Yep. And then to do the problem, what I would do is I'd FOIL that out and multiply by x. I'm just about out of time, so I'm going to give you kind of the abbreviated version.
Can you go through the FOIL because on the test I didn't know how to go farther than that.
Okay, yeah, if I FOIL, that's going to be 90 minus 15x minus 18x plus 3x squared. So that's going to give me, what, 3x squared minus 33x plus 90. And then I need to multiply again by x. I do that, that's cubes and squares and x's.
In the auditorium at 9 o'clock in the auditorium, everybody should be there. Thank you.
Okay. Somebody's got somebody has a assembly. Then we take the derivative, which gives us the ugly 27x squared minus 66x.
Just mention one more time, I apologize. It is going to be in the high school cafeteria, meeting at 9 o'clock in the high school cafeteria. Thank you.
Now the part that's ugly on this one, and it's one of the reasons why it makes a take-home question versus a not take-home question, is you need to know where that's equal to 0. So you either approach it by trying to factor it or by throwing it in the quadratic formula. The nice part is you can start off by dividing by 3. So you do end up getting 9x squared minus 22x plus 10. Reduces the numbers a little bit, but they are kind of ugly numbers. So you kind of crank through from there. So, and again, you get ugly numbers, but ugly numbers, usually on the final you don't get ugly numbers. On something like this, it's a take-home, you might get ugly numbers. Well, we're more than out of time, and I know Ryan's got a place to go, and some of you have to be someplace at 9 o'clock, it sounds like. So have a good one. I'll see you on Wednesday. And I'll remind you we're going to meet for an optional review session on Thursday as well.
Aaron,
Yes?
if we get to the final, we get like I don't need to tell you what to do next.
You're going to get more credit than if you don't. Let's put it that way, yes. If you could tell me what the process is and you can't execute, you're going to get some of the credit, definitely.
Thank you.
You're welcome. Have a good one.